Objective 5. Explain the difference between correlation and causation. We have discussed two types of studies: observational studies and design experiments. The club head speed data examined in examples 1, 3, and 4 are the result of an experiment. Therefore, we can claim that a faster club head speed causes the golf ball to travel a longer distance. That is, there is a causal relationship between club head speed and distance. If data used in a study are observational, we cannot conclude that the two correlated variables have a causal relationship. For example, the correlation between the teenage birth rate and homicide rate since 1993 is 0.9987, but we cannot conclude that higher teenage birth rates cause a higher homicide rate because the data are observational. In fact, time series data are often correlated because both variables happen to move in the same or opposite direction over time. Both teenage birth rates and homicide rates have been declining since 1993, so they have a high positive correlation. Is there another way two variables can be correlated without a causal relationship existing? Well, yes, through a lurking variable. For example, as air conditioning bills increase, so does the crime rate. Does this mean that folks should turn off their air conditioners so that crime rates decrease? Well, certainly not, but in this case, the lurking variable is air temperature. So as air temperature rise, both air conditioning bills and crime rates rise. So, in a caution for this, does correlation imply causation? Not always. Okay, we cannot make statements of causation if the data are observational. However, if the data come from a design experiment, correlation does imply causation. So, for example, lurking variables in a bone mineral density study. Because cola tends to replace healthier beverages and cola contains caffeine and phosphoric acid, researchers Kathleen L. Tucker and associates wanted to know if cola consumption is associated with lower bone mineral density in women. The table below here lists the typical number of cans of cola consumed in a week and the bone mineral density for a sample of 15 women. The data were collected through a prospective cohort study. The figure to the right here shows the scatter diagram of the actual data. The correlation between number of colas per week and the bone mineral density is negative 0.806. The critical value for correlation with n is equal to 15 from that table 2 is 0.514. So let's go ahead and bring that in so we can see what that means. If I take this critical value here, okay, here is our critical value chart. Let me go ahead and minimize that. So recall that we have a sample size of 15. So if we come down here at 15, then what is the critical value? Well, we can see that the critical value is 0.514. Okay? And we know that the correlation from the example is negative 0.806. Now, if we take the absolute value of negative 0.806, it gives us a positive, and we know it's going to be greater than the 0.514, which tells us that we have a negative linear relation that exists between number of colas consumed and bone mineral density. Now, can the authors conclude that an increase in the number of colas consumed causes a decrease in bone mineral density? Identify some lurking variables in the study. Well, to claim causality, we must collect the data through a design experiment. And remember, lurking variables are related to both the explanatory and response variables in a study, and this relation causes the apparent association between the explanatory and response variables in the study. In the problem statement, we learned the data were collected through a prospective cohort study. Therefore, the data are observational. So the researchers cannot claim that increased cola consumption causes a decrease in bone mineral density. In their article, the authors identified a number of lurking variables that could confound the results. Variables that could potentially confound the relation between cola consumption and bone mineral density include the following: age, body mass index, height, smoking, average daily intake of alcohol, calcium, caffeine, total energy intake, physical activity, season of measurement, estrogen use, and menopause status. The authors were careful to say that increased cola consumption is associated with lower bone mineral density because of potential lurking variables. They never stated that increased cola consumption causes lower bone mineral density.